You've probably seen it happen. A cat falls, twists in midair, and lands perfectly on its feet. Every single time. Almost like it's cheating physics. So is it magic? Is it luck? Or is something else going on? The real answer involves biology, physics, and one very specific body part cats don't even have. Wait, what? A body part they don't have helps them do this? Stick around, because near the end, I'll show you the surprising height rule. The one that actually makes falling from higher up sometimes safer. Yeah, you read that right. Let's get into it. This whole ability has an actual scientific name. It's called the riding reflex. And it kicks in almost instantly the moment a cat starts falling. We're talking a fraction of a second, faster than you can blink. The reflex starts in the inner ear. Cats have an incredibly sensitive balance system in there. It's called the vestibular system. It constantly tells the brain which way is up. Even with their eyes closed, cats can sense their orientation in space. The moment they sense they're upside down, the reflex fires automatically. It's not a decision. It's automatic, like a reflex when a doctor taps your knee. Now here's the body part twist I mentioned earlier. Cats don't have a functional collarbone. Well, technically they have a tiny floating one, but it's barely attached to anything, which means their shoulders aren't locked to their rib cage like ours are. That gives them incredible flexibility most animals simply don't have. Combine that with an extremely flexible spine. Cats have far more vertebrae than humans do in their back. This means their front half and back half can basically rotate independently. Picture twisting the top half of your body one way while your hips stay still. Now imagine doing that fully, instantly, while falling through the air. That's essentially what a cat does every single time it flips over. Okay, but here's a question that actually puzzled scientists for a long time. If a cat has no solid surface to push against in midair, how does it rotate at all? Shouldn't that break the laws of physics? This is where it gets genuinely clever. The cat doesn't rotate its whole body at once. It bends in the middle first, tucking its front legs in. Tucking a limb in close to the body reduces resistance to spinning, while extending the back legs out increases resistance to spinning. So the front half spins fast, while the back half barely moves. Then the cat reverses it, tucks the back legs, extends the front. Now the back half spins, while the front half stays steady. Repeat that twice, and the entire body has rotated a full 180 degrees. No pushing off anything. No violating physics. Just clever body mechanics. It's the same principle ice skaters use to control their spin speed, just applied by an animal completely instinctively. Now, this reflex is fast, but it's not instant. It actually needs a small amount of falling time and distance to complete. Most experts estimate cats need at least around 12 inches to fully right themselves. That's barely 1 foot of height, which is why a cat falling off a low couch usually still lands fine. There's just enough time for the reflex to kick in. But it also means a fall from a very short height, like just a few inches, doesn't give enough time. So no, dropping a cat from your hand onto a table isn't a fair test of this reflex. Please don't try that, by the way. Now let's get to that surprising height twist I promised earlier. Veterinarians actually have a name for cats falling from tall buildings. It's called high-rise syndrome. And here's the part that shocks almost everyone. A well-known veterinary study looked at cats that fell from various floor heights. Cats falling from higher floors, like 7 stories or more, sometimes had better survival odds than cats falling from middle floors. Wait, what? Higher should be worse. That seems completely backwards. Here's the leading theory why. Cats reach a maximum falling speed called terminal velocity. For cats, that speed is reached faster than most people expect. Once they hit terminal velocity, they stop accelerating. At that point, some researchers believe cats actually relax their bodies. They spread out like a tiny parachute instead of staying tense. A relaxed, spread out body distributes impact force more evenly. A tense, narrow body concentrates that same force into a smaller area. So paradoxically, more falling time might mean a calmer, better prepared landing. To be clear, this doesn't mean tall falls are ever safe for cats. Survival rates still generally drop at extreme heights, and injuries remain common. It's a fascinating pattern in the data, not an invitation to test it. So what does the actual landing look like, physically? By the time a falling cat is closer to the ground, its body is already positioned. All 4 paws are pointed downward, spread slightly for balance. The back arches slightly to help absorb the shock of impact. Their legs act like natural shock absorbers, bending on impact. This is very similar to how a gymnast bends their knees after a jump. Cats are essentially doing a perfectly timed, instinctive gymnastics landing. Every single time, without ever being taught how. Now, I want to be honest about something important here. This reflex is impressive, but it is not a guarantee of safety. Cats can still be seriously injured from falls, especially from high places. Broken bones, chest injuries, and worse are genuinely possible. Veterinarians see fall-related injuries in cats fairly often, especially in cities with tall buildings. This is actually why many vets recommend secure window screens for indoor cats. The physics is impressive. It's just not invincibility. So how did humans even figure out the mechanics behind all this? In 1894, a French scientist named Étienne Jules Méry studied this exact question. He used an early high-speed camera to capture a falling cat frame by frame. It was one of the first times anyone had frozen this motion clearly enough to study it. His photographs proved the cat wasn't rotating its whole body at once. It confirmed the twisting, sequential motion we just explained. This research became genuinely important far beyond just curious cat owners. Decades later, physicists and engineers studied the same footage again, because understanding how a body can rotate without pushing off anything turned out to be incredibly useful for a very different field entirely. That field, space travel. Astronauts in zero gravity face the exact same problem a falling cat does. No ground to push against. No walls nearby. Just open space. Researchers actually studied the cat riding reflex to help understand how astronauts could reorient their bodies in orbit. The same tuck-and-extend principle applies. Move one part of your body to control rotation. It's a strange thought. Cat physics helped inform actual space research. Nature figured out orbital mechanics tricks millions of years before we did. Are cats the only animals that can do this? Not entirely, but they're by far the best at it. Rabbits have a weaker version of the same riding reflex. Some other small mammals show traces of it too, just less refined. Dogs generally do not have this same ability nearly as well. Their spines and shoulder structure just aren't built the same way. And humans? We really don't have this reflex in any meaningful way. Our collarbones lock our shoulders in place, and our spines are far less flexible, which is exactly why gymnasts and divers have to train for years to control body rotation in the air. Cats are just born already knowing how. Actually, let's slow down on that kitten point for a second. Newborn kittens can't actually do this reflex yet. Their balance system and coordination simply aren't developed enough at birth. Around 3 to 4 weeks old, the reflex starts to appear in a clumsy, partial form. It genuinely looks uncoordinated at first, kind of like a toddler learning to walk. By 6 to 7 weeks, the movements start looking much smoother and more controlled. And by around 9 weeks, most kittens have the full adult version down completely. It's a great example of a reflex that's instinctive, but still needs time to fully develop. Let's dig a little deeper into that terminal velocity idea from earlier. As any falling object speeds up, air resistance pushes back against it harder. Eventually, that resistance balances out the pull of gravity completely. At that point, speed stops increasing. That's terminal velocity. For a falling cat, that speed is roughly 60 miles per hour, which sounds fast, but it's actually much slower than a falling human reaches. Cats are lighter and have a higher surface area relative to their body weight. They're spread out. Relaxed falling posture increases that surface area even more. More surface area means more air resistance, which means a lower top speed. It's a small built-in advantage most people never think about. Let's clear up a few myths while we're here. Myth 1. Cats use their tails to do this. Not really true. Manx cats, a breed born with no tail at all, can still perform the riding reflex just fine. The tail might help slightly with fine balance, but it isn't the main mechanism. Myth 2. Cats always land completely unharmed no matter what. We already covered this. It's false, and it can be genuinely dangerous to assume otherwise. Myth 3. Kittens are born already able to do this perfectly. Also false. The reflex actually develops gradually over the first few weeks of life. By around 6 to 9 weeks old, most kittens have it fully down. Myth 4. This reflex means cats can survive falls from literally any height. Physics still applies. There's a real limit to what any body can survive. Let's end the deep dive with a few fun facts. The riding reflex fully engages in as little as an eighth of a second. That's faster than most human reflexes we're even aware of. There's a real, documented case of a cat surviving a fall from over 30 stories up. It's an extreme outlier, not something to expect or rely on. Cats aren't the only animals with a strange, fall specialty either. Flying squirrels use a stretched skin membrane to glide, a totally different trick for a similar problem. Nature really has found a lot of clever ways to survive a fall. One more fun detail. Bigger cats have this reflex too, not just house cats. Lions, tigers, and leopards all share the same basic riding ability. It makes sense. They're all built on the same flexible spine design. Even cats that have never fallen from a height in their life still have the reflex ready to go. It's built into their nervous system from birth, fully wired and waiting. Quick pause. Before the recap, take a guess. Do you think declawed cats can still perform the riding reflex normally? Yes, completely. Claws have nothing to do with this reflex at all. It's entirely about the inner ear, the spine, and the shoulders. Okay, let's bring this all together. Cats land on their feet because of a genuine biological reflex, not luck. Their inner ear tells them instantly which way is up. Their flexible spine and near-absent collarbone let their body twist in two independent sections. Tucking and extending limbs controls the speed of each half's rotation. It takes about 1 foot of falling distance to fully complete. And surprisingly, extreme height doesn't always mean extreme danger, though it's still genuinely risky. This same research even helped scientists understand rotation in zero gravity. All from one simple, curious question about falling cats. If this answered a question you never knew you had, that's exactly what this channel is about. So if you enjoyed this, hit subscribe so you don't miss the next one. It genuinely helps this channel grow, and it takes about 2 seconds. Drop a comment and tell me which part surprised you the most. Was it the no collarbone thing? The high-rise syndrome twist? Let me know. And if you like this video, go ahead and tap that like button. It's a small click that genuinely helps this channel keep growing. There are hundreds of everyday questions just like this one waiting to be explored. Things you've seen your whole life, but never actually questioned. That's what this channel is all about. Toggling your curiosity on, one question at a time. One more thing before you go. Tap that notification bell too, so you actually see it when the next video drops. Next time, we're tackling why flamingos stand on one leg for hours without falling over. It's a surprisingly clever energy-saving trick, and you will not guess the mechanism. I'll see you in the next one.